Hello everyone, in this video we are going to discuss how file locking can be used for process synchronization. File locking is basically a mechanism that restricts access to a computer file or portion within the file by allowing only one process to modify the file, and also it prevents others from reading the file while the file is being modified. Thus, cooperating processes can use file locking for accessing and updating a shared file. Let's see an example of a deposit and a withdrawal processes in a banking application that are accessing a shared file called account.txt. So, there's a protocol that these processes have to follow. First, it has to open the file. Then, it has to try to acquire the file lock. If the file is free, it has to set the lock, perform the operation. And once the operation is performed, it has to release the lock. If at all, if the file is already locked by some other process, the process has to wait until the lock is released by the other process. So every process has to follow this protocol of acquiring the lock, setting the lock if the lock is free, perform the operation, and then release the lock. So now, say deposit process, it tries to acquire a file lock on the file account.txt and write and update as balance is equals to balance plus 200. Now, as the file is free, it obtains a write lock and performs its operation. Now, at the same time, say withdrawal process tries to acquire the file lock on account.txt to update the balance as balance minus 100. Now, as the file is already locked, it has to wait for the process deposit to release the lock. The withdrawal process cannot proceed to acquire the lock. Now, once the process deposit has done its updation, it can release the lock. Now, the process withdrawal, which is waiting to acquire the file lock on account.txt, it acquires the file lock and updates the balance is equals to balance minus 100. Now, process withdrawal, as it is done with its updation, it releases the lock so that other cooperating process can perform the read and write operation on the file. So, this is how the cooperating processes have to acquire the lock, perform the operation, and release the lock in a synchronized way. Now, to set and unset the locks, we use fcentail function. Fcentail function basically has many purposes. One of the purpose is to obtain lock on the files. So this function, it basically takes n number of parameters. For example, as you can see here, it takes unlimited number of arguments, but for fcentail, but for our locking and unlocking purpose, we are using 3 arguments. The first argument is fd, which is nothing but a file descriptor, or which is returned by open system call. It's the file descriptor of the open system call. The second argument is the command. The command is tells us what operation you want to perform on the file. So the command value can be f_get lock. So get lk. So it gets the information about the lock that is set on the file. It can be f_set lk. So this is used to set the lock on the file. The command is set if the command is f_set lk, it means that you are trying to set the lock on the file. If it is f_get lk, it means that you are trying to get the information about the lock that is set on the file. Similarly, fset lkw. So this is used to know what portion of the file is locked. So basically, again, this third one is to acquire the information about the lock that is set on the file. Then the third argument, it's an address of type struct flock. And this fcentail function, it returns -1 on failure, and upon success it returns different values depending on what operation you are trying to perform. So the third argument is address of struct flock, right? So let's understand this structure. So it has got different various members. These are the members which are required for setting the lock. So the first one is L_type. So what type of lock you want to set? So if it is a read lock, this value should be f_rdlck. If it is write lock, it should be f_wrlck. If you want to unlock the file, then this L type should be f_unlck. Now, the second member, whence. Whence will first see the start and then whence. So start indicates from the starting offset from where the lock is to be set, and its value can be seek_set. It means it should be set from the beginning of the file. seek underscore cur, it means from the current position of the file offset. The lock should be set from the current position of the file offset, and seek underscore end in the sense from the end of the file. So the start, it can take any of these three values. So if it is seek underscore set, it's from the beginning, seek underscore cur from the current offset, and seek underscore end from the end of the file. So whence, next is this whence. Whence tells us from where, from what position with respect to the start. Like say for example, if I give 10, if I give the value of whence as 10, then it means that 10 bytes from the start. Whatever start, say you have given seek underscore set, it means that 10 bytes from the beginning. Seek underscore cur, if you have given 10 bytes from the current position. Also you can, whence can take these values also, seek underscore set, seek underscore cur, seek underscore end also you can give, and but it will be always with respect to L underscore start. Then the fourth member here, L underscore length, the number of bytes you want to lock on the file. As we have discussed, the FCNTL function can be used to lock the entire file or just a portion of the file. So this length specifies the number of bytes to lock. And third one is the PID, process ID of the process which has locked the file. So when you use this get LK function, get LK command, you can get the PID of a process from this member. So this is about the function that we have to use for locking. First we have to open the file. The open function returns the file descriptor, so that is given as the first parameter. Then the second is a command, right? We have to use command depending upon purpose, get lock, set lock, or set LKW. And to set the lock, we have to give the third parameter of type struct flock, and we have to initialize these values and then pass the address of struct flock as a third argument to SCNTL. Let's see the execution. Let's see the program and the execution. So here we have initially used all the header files. We are taking the file name as an argument to this program on which the lock is to be set, right? Hence we are using here int argc char star argv to accept the command line argument. So we will be passing the file name as an argument. Then here we are declaring the various things, right? You can see fd, buffer, and flock. Now if the argument is equal to 1, it means that you have not passed the file name as an argument. Then it prints error message usage. You have to use provide the file name and returns -1. That is, the program terminates. If you are not providing the file name, it just prints this error message and then it terminates. If you have provided the file name, right, then it opens the file. You can see here it is opening the file in read-write mode, and then that open files file descriptor is returned by the open, which is assigned to FD. Now if FD is equal to -1, it means that there was some error in opening the file. That error you are going to print using perror function, and you are going to exit, right? So now suppose the file has been opened. Now we have to define the members. We have to set we have to initialize the members of struct flock. So here you can see fvar is the structure that we have declared here, struct lock fvar structure object. So L type we are setting as f underscore wr lock, ins write lock, start from the beginning, seek underscore set from the beginning, whence means from whatever position the start is, from that position, and from the length of the lock we are specifying as 100. Now we are printing the message to the user, press enter to set lock. So the moment we are reading just the enter what the user press using getChar function, and then we are printing a message trying to get lock. Now you can see we are using FCNTL function. We are passing the file descriptor. We are giving the command f underscore set lock, and we are passing the address of this fvar structure which we had just initialized. If we are successful in setting the lock, it will return 1. Otherwise, if it fails to obtain the lock, it returns -1. So when it returns -1, we are printing the error message perror, and also we are trying to see which process has set the lock. So for that, I'm calling FCNTL again here, right? Passing the file descriptor and passing the command f underscore get lock. So this get lock command will get the information about the lock that is set. So that information will be stored in this fvar. Now we are printing that information. That file is already logged by the process ID. You can see fvar.lpid, right? And then you return -1. So if you are able to set the log, then fcntl returns 1 and you will be out of this if. Suppose if the file is already logged by the process, some other process, it's going to return -1. So this will be true, and you are going to come in, you're going to print the message, and also you're going to get the information about the process, like which process has locked the file using f_get lock, and then you're printing that process ID, right? And then you're performing the write operation. If you are successful in obtaining the lock, you're printing the performing the write operation. Now it's time to release the lock. So you're asking the user, press enter to release the lock. So get char, and you're just reading the enter, whatever enter character. Now you're initializing the fvar members. Type the L_ type will be unlock, and when sys set start is 0, and in the sense 0 sense from the beginning of the file. Length is 0 in the sense the complete. If length value is 0, what instead of meaning as a 0 bytes, it means that the entire file has to be locked. The length value 0 has got special meaning in fcntl. If length is 0, it means that the entire file. Then once you've initialized all the members, you're calling fcntl and you're passing set lock. Set lock basically, here as the lock type is unlocked, it's going to unlock the file. So in case there is an error, it's going to print the error message. Otherwise you get the message unlocked and the file will be unlocked. Let's see the execution of this. I'm compiling this file and I'm trying to set the lock on a file, say b.txt. So it says press enter to set the lock. I'm pressing enter. It's saying trying to get the lock, and the file is logged. So now you can see the file is logged. In this another window, I've opened another window, terminal window, and I'm now trying to set the lock on the same file. You can see I'm trying to set the lock on the same file. The file has already been locked by the in the other window, right? So now you can see it is asking press enter to set the lock. I'm pressing enter. So it is saying trying to get the lock. So this is the message printed by the PERROR function, lock resource is temporarily unavailable, and you can see it's printing message file is already logged by process ID 7151. So in this way, this as the file is already logged by the process, it's not allowing the process to log the file. So this is all about the file locking for process synchronization. Thank you.